Let's talk about inverse variation. This is an inverse relationship between the two variables. We say y varies inversely as x, or y is inversely proportional to x, if a situation is described by an equation of the form y equals k over x, where k is the constant of variation. This one, I want you to think about that relationship where x is in the denominator and k is a constant. That is this function. Remember, y equals 1 over x looked like this. The k would just be a stretch of that. And so that is the relationship, or the graph that you're sort of looking at here. Many situations that we look at, not all, but many situations that we look at require the variables be positive, so you're looking at this relationship. And it's not just about increasing or decreasing. One thing I should emphasize about direct variation, I said that was a linear relationship back here, and that is true. It is a linear relationship. But one thing that's important to remember is the k could be negative, so this line could, oops, gotta hit that intercept there, could go this way if the slope is negative. And that can happen. So as one variable increases, the other one could decrease. And so that is a possibility. But here you definitely have that relationship where as one variable increases, the other one decreases. As this variable, say this is x, gets bigger and bigger and bigger, y gets smaller and smaller and smaller. So that is definitely going to happen in this situation. What we're really mostly interested here is that inverse idea where you have, it's a non-linear rate of increase or decrease. Rate of decrease, I guess, in this case. These examples, the rate of travel and the time needed to travel a certain distance. So we're talking about rate, time, and a certain distance. We know that distance equals rate times time, right? If d is fixed, a fixed number, a certain distance, we're talking about a constant number there, then r would be equal to d over t, and that is exactly inverse variation. Because d is a constant, r and t would both be variable, right? As r increases, as your rate increases, the quicker you travel, the more quickly you travel, the shorter the time to go, say, 100 miles. So that is inverse variation for sure. The number of pages you read in a book and the number of pages you have left to read. Well, let's say the number of pages you read in a book is R, and what you have left to read is L. The relationship between these is going to be R, or let's do this, it might be easier to see it this way. What you have left to read will equal the total number of pages minus what you've read. Number read, right? So L, so number left, L would equal some constant, let's say total T, minus the number of pages you've read, right? The sum of what you've read and what you have left has to equal the total number of pages. So when we subtract that over, we get this. This is not inverse variation. You don't have that variable in the denominator. It is true that as one variable increases, the other one decreases, but it's not in the correct format here. The number of children present and the number of cookies each can have if a box of cookies is divided evenly. Well, a box of cookies has a fixed number of cookies, right? Number of cookies total. And if you're dividing it evenly, the number of cookies total has to equal the number of children times the number of cookies each, right? So let's give these each a letter. T would equal, the number of children present is a constant, right? That's some constant. And then the number of cookies that they each get, I don't know, let's call it N for number. This is going to be the relationship between these. Oh, no, I'm sorry. The C is not constant. The number of children is not constant. The number of cookies is not constant. But the number of cookies in the box, the total number of cookies, is a constant, right? That box of cookies has however many. So if you want to know the relationship between how many kids and the number of cookies, it's going to look like this, where this T is constant. So that is inverse variation. You have one variable in the denominator over a under a constant. Okay. And kids know that, right? They know that as the number of kids, if you have a box of cookies and there are 2 kids there, they know that the number of cookies that they may get is going to be bigger than if there are 10 kids there, right? So kids know that there's that inverse relationship there. Let's look at an example. To continue making money, the number of new songs S a rock band needs to record each year varies inversely as the number of years the band has been recording. Let's write that relationship. If it varies inversely, the number of new songs S varies inversely as the number of years N the band has been recording. So we're going to use that proportionality constant K. Hopefully that kind of makes sense, right? The number of years they've been recording, as that goes up, they get a stronger following, and so the number of songs that they would need to record each year would decrease because they're going to have still people listening. They're going to have a following, right? So those, you can see an inverse relationship there. After 4 years of recording, a band needs to record 15 new songs per year to be profitable. Let's plug those in and see if it can help us find out what the K is. S is the number of new songs, so that's 15. We do not know K. N, number of years recording, is 4. That tells us when we multiply both sides of this by 4 that we get K is 60. So the relationship, the variable relationship, is S equals 60 over N. Remember that K is a constant. But the N and the S are different, right? Different bands have been recording a different number of years, and so need different number of songs recorded. After 6 years, how many new songs will the band need to record in order to make a profit in the 7th year? So S, how many new songs will they need? You're being asked to find S when N is 6, right? How many years they've been recording? They've been recording 6 years. 60 over 6, S equals 10. So they would need to record 10 songs. Okay. The key there is this very first sentence, to write that relationship, write that equation. And once you get that relationship written down, that equation written, you have to find the K. And then from there, you can find whatever piece of information you're looking for. Let's talk about combined variation. Direct and inverse variation can occur at the same time. Here's an example. The number of minutes to solve math problems on a worksheet varies directly as the number of problems and inversely as the number of people working to solve the problems. So imagine you are working in a group, right? You have a certain number of problems, however many that is, if that goes up, the time to solve the problems is going to increase, right? But if you have more people working on them, that time to solve the problems will decrease. We need to give some variable names here to each of these, or some letters to each of the variables here. The number of minutes to solve math problems on a worksheet, I'm going to call that T for time. The number of problems, let's call that N for number, and the number of people, can we call that P? When we go to write that equation, we say T, the number of minutes, or time will equal, it varies directly as the number of problems, so that's Kn, and inversely as the number of people. We don't need to institute another constant, because if you had another one in there, they'd be multiplied, and a constant times a constant is still a constant, so we don't need to complicate it with extra constants in there. So that's our equation. It takes 4 people 32 minutes. So 32 is equal to K times N represents the number of minutes. Number of problems, 16 problems. P represents the number of people. All right. N is number of problems, so that N gets replaced by the 16. This is N equals 16. The 32 minutes tells us T is 32, and the 4 people tells us that P is equal to 4. So I just put those all in place there to find the K. Simplifying that, we get 4K equals 32, or K equals 8. So I'm going to write my equation. T equals 8N over P. I found my proportionality constant. So now I have that relationship between these 3 variables. I haven't even looked at what the question is really asking yet. I just know that I wanted to know that relationship between them. How many minutes will it take 8 people to solve 24 problems? So the question is asking you to find T, that's the number of minutes, when the number of problems, N, is 24, and the number of people, P, is 8. So let's plug that in. N is 24. P is 8. Well, the nice thing about that is those simplify because they're equal. And you get T is 24 minutes. The key here is keeping track of those variables, right? Give them a name and make sure it's clear to you how you named them. The last type of variation is joint variation. And that is where you have a quantity varying directly as the product of 2 or more other quantities. So we are looking at, again, multiple variables involved here. This example that we're going to look at is actually combined joint, but it doesn't matter. We just have to be really careful to read along with exactly what it says and put things in the appropriate places. The centrifugal force, C, of a body moving in a circle varies jointly with the radius of the circular path and the mass's body, and inversely with the square of the time, T, it takes to move about 1 full circle. Okay. Centrifugal force varies jointly with the radius of the path, of the circular path, so the radius and the mass of the body that's moving on it. So I need K for my proportionality constant. That's the easiest thing to forget because it's not explicitly stated, but anytime we have variation, we are talking about some proportionality constant times whatever is given. Jointly with the radius and the mass, so that means those two multiply together, that's the product. And inversely, that puts it in the denominator. We have our k, so we don't need another one, with the square of time. So that would be t squared. It takes to move about one full circle. That is my relationship. The only thing I don't know is that proportionality constant. Let's see if we can figure it out. A 6-gram body moving in a circle with radius 100 centimeters at a rate of 1 revolution in 2 seconds has a centrifugal force of 6,000 dynes. Find the equation that describes this situation. I am not going to expect you to know like all these units and what is appropriate here. So like what is a dyne, for example? A dyne is a unit of force that, when acting on a mass of 1 gram, so we're in the right units there, increases the velocity by 1 centimeter per second every second in the direction it acts. So the important thing there is that it does deal with grams, centimeters, and seconds, so you don't have to worry about doing any conversions here, like from centimeters to meters or anything like that. It is all good, so we can just work with these numbers as they are. This is not something that I would expect you to know in this class. We are given that C, centrifugal force, is 6,000 dynes. We are given that I'm just going through the variables here. The K is, it's a constant, it's an unknown constant at the moment. R is the radius, that is 100 centimeters. M represents the mass, that is 6 grams. And then T is 2 seconds. It takes 2 seconds to go 1 revolution. We're going to use all of those to find the K. And this question is just asking for us to find the equation that describes this situation, which really we have except the K. We need to find what that constant is. And we do that by plugging in these numbers. 2 squared. 6,000 equals, that is 600 K over 4. 600 over 4 would simplify down to 150 K. That may be the easiest way to simplify this. Dividing the 6,000 by 150 gives you what, 40? 4 times 150 is 600, so yep, 40. Okay, that means our equation, we got to plug that back in, right? Looking up here at this, K R M over T squared. So that formula can be used in this particular situation for centrifugal force. There's some pretty cool physical applications in our physical world of all of these types of variation. We saw a few with Hooke's law and the centrifugal force, and just various things that our world abides by, these proportional relationships between variables. So it's kind of cool to see that. That wraps up Unit 3. We saw a lot in Unit 3, lots of different types of functions. Sometimes I like to tell my students that college algebra is really the study of functions. So far we've studied linear functions, we've studied quadratic functions, we've studied polynomials, recognizing that quadratics and linear are specific types of polynomials. We studied rational functions. We're going to keep studying different types of functions. Next, we're looking at exponential and logarithmic functions. So college algebra really is the study of functions.